The concept of a function can sometimes be a confusing concept for a student. So I'm going to talk here briefly just about what a function is and how to tell if something is a function based on a chart, a table, or a graph. So anyway, we'll look at beginning here what a function is. So the formal, well, this isn't a super formal definition, but a definition for a function would look like this. It's a relation where every x value has exactly one y value. Okay, so the key here is that every x value, so if we have, two columns here with an x and a y, every single x value would have to go to exactly one y value. So each x has to go to exactly one y. As soon as you have an x, let's put another number up here like 0. As soon as you have an x that goes to two different y values, now you have something that is not a function anymore. So currently what I have up here is not a function. Again, if we wanted to make it a function again, all I'd have to do is erase this part, and now every x goes to exactly one y. It is important to note here that, if we had another number, like let's say 8, an x value is allowed to go to the same y value as long as that x value does not go to two different y values. Okay, so functions are predictable. Every time you input something, it should give you the same output every time. So if you put in a 3, you get a 9. If you put in an 8, you get a -1. If you put in a 7, you get a -1. If you put in a 2, you get a 5. That's predictable. As soon as we have something like this where we have another number, well, now if we put in a 2, we don't know if we're going to get a 0 or a 5, so that would not be a function anymore. All right, so let's flip on here and talk about how to tell if the relations are functions. And I already sort of looked at a mapping earlier when I was writing my example. We know that -2 goes to -8, 0 goes to 0, 2 goes to 8, and 4 goes to 16. This is a function. Every single x value goes to exactly one y. If I had a -2 also going to, let's say, 0 or 8 or all the above here, that would no longer be a function. Okay, so I'll erase that just so I don't confuse you. Okay, we'll look at this chart here over on the right next. So we've got 3 goes to 2, 1 goes to -2, 2 goes to -4, and 3 goes to -1. Okay, if we look carefully here, these two x values are the same. So when you're trying to identify if something is a function or not, it's helpful to recognize if any of the x values repeat. Notice here that these x values are 3. 3 goes to two different things. It goes to 2 and to -1. So if there's repeated x values that go to different y's, that is not a function. Okay, so that would not be a function. All right, next up we've got 3, 5, -2, 4, and 1, 4. We've got a set of ordered pairs here. So just to help myself out, I'm going to write an x and a y above each of these. Sorry that this is a little hard to write on sometimes. Okay, so we've got an x and a y above each of these. Let's see. 3 goes to 5, -2 goes to 4, and 1 goes to 4. Now, it might be tempting to say that this is not a function, but this actually is a function. Every x, we're not worried about the y's repeating. We're worried about the x's repeating and going to different numbers. Every x goes to exactly one y. If I were to even draw it out this way as, a mapping, you might be able to see it better. So we'd have 3, -2, and 1, and then we have 5 and 4. You can see that every x goes to exactly one y. We didn't have -2 in there also going to another number, so if I added another ordered pair like -2, 0, now it wouldn't be a function anymore because -2 would be going to some other point. Or if I had -2, 8, that would also be a problem because -2 is going to some other number. So that's just a little introduction on how to tell when something is a function by looking at a chart or a table or a mapping. So now let's look at what's called the vertical line test. This will be the last thing we'll talk about here. So the vertical line test says, if at any point on the graph of a relation you can draw a vertical line and have it cross through more than one point. The relation is not a function. So what this means is, remember that vertical lines, vertical just means it goes straight up and down. When you're going through this, let's see here, if I've got let's make a graph that looks like this. Let's say that this is the graph of some relation that I have. If I can draw a straight up and down line at any point on the graph and hit multiple points, more than one, this is not a function. So what I've just drawn up here is not a function. Okay, let me try showing you another example here. Again, if I've got a little graph here that I'll make. Let's try another one. Let's do something like this. Let's draw a little line that maybe does one of these things, curves around, and does that. Okay? So again, if we're checking this, if I draw a vertical line, and you might see here, if I drew a vertical line out here, we're actually okay. It appears to be a function, but it has to be okay over the entire graph. So if I can find any spot on the graph, like even right here, where it's hitting more than one point, this is not a function. Well, let's look at an example that might be a function here. Okay, if I were to draw a graph that looked something like this, okay, I'll put arrows on the end to show that that might go on forever. If I keep drawing up and down vertical lines, I'm never hitting a spot where the x value repeats or it's going to cross more than one point. So this would, yes, this would be a function. Okay, and I'm actually going to rewind here back to a previous example to kind of show you how this all connects. So if you're good at this point, feel free to turn the video off, but this might be a little interesting connection here where I link it to what we just did, where the x values repeat. Okay, so let me clear up some space here. So this is how it's all connected. If you look here, let's just make something that we know is not a function. So we'll do 3, 4. We'll do 3, -2. We know that since this x value repeats, this cannot be a function. And we'll do 1, 0. And we'll do -2. Let's go with -3. That'll work. Okay. So I know that these 2 points, since the x value repeats, should cause it to not be a function. Let's look at what this actually looks like if I graph it so we can see how it's all connected. So I'm going to just draw some lines here. 1, 2, -3. -1, -2, -3, and 1, 2, and 3. Okay, so I'm going to start by graphing the point 3, 4. Oh, I guess I need one more arrow up here. So 3, 4 would be up here somewhere. Now I'm going to graph the point 3, -2. Then I'm going to graph the point 1, 0. And I'm going to graph the point -2, -3. Okay, you can see from this graph that if I were to extend this line down, right here it hits 2 different points. So this is not a function. So you can see that when the x values repeat, it causes a spot on the graph where it will fail the vertical line test. Okay, and that's just a little introduction to functions. Again, one more little thing that I want to touch on that sometimes comes up. Again, I'll clear this off here to talk to you guys. Something called a step function. It's really not something that's used too much to teach in Algebra 1, but they may ask you if this is a function or not. And they'll use these little open circles here to see if you're paying attention. Okay, so the open circle means that everything up to this point is included in this line here, but right when you get to this spot, it's not included. So if I were to draw a line straight down, this point does not count as crossing over the graph. So here we are only crossing once. Here we are only crossing once. If that was a closed circle, then this would not be a function because you'd be hitting more than one point. But that's a step function, just one more little thing that you may see on a problem that you're working on if you're looking at functions.